Welcome to today's video on section 10.6 and the fundamental counting principles. The first thing we're going to talk about is the fundamental counting principle, and that's the number of ways in which a series of things or events can occur, and that's found by multiplying the number of ways in which each event occurs. So for example, here, if you own 30 pairs of jeans, 20 t-shirts, and 12 pairs of shoes, how many different wardrobe combinations can you make of jeans, t-shirts, and shoes? So if you multiply 30 times 20 times 12, you get 7,200 choices. And that's how many different combinations you could make for your wardrobe. If you have a pizza that can be ordered with 3 choices of size, so you could do small, medium, or large, 4 choices of crust, thin, thick, crispy, or regular, and 6 choices of toppings, ground beef, sausage, pepperoni, bacon, mushrooms, or onions, how many different one-topping pizzas can you make? So you're only choosing one of each thing. So you have 3 choices of size. You have 4 choices for crust, and you have 6 choices for toppings. So you have 72 different pizzas that you could create. If you're taking a multiple choice test that has 10 questions, and each test has 4 answer choices like A, B, C, D, with 1 correct answer. If you select one of these 4 choices for each question and leave nothing blank, in how many different ways can you answer the questions? Well, if there's 10 questions and there's 4 choices, so basically it's 4 to the 10th, which is 1,048,556 ways that you have to answer that question. License plates in a particular state display 2 letters followed by 3 numbers, such as AT887. How many different license plates can be manufactured? Well, remember, they don't say anything about repeating. So that's assuming that you can have repeating either letters or numbers. So remember, there's 26 letters, so there's 2 letters that you need, and then there's 10 numbers, 0 through 9. So when you multiply 26 times 26 times 10 times 10 times 10, oops, sorry about that, you get 26,000. Actually, sorry. You get 676,600. $676,000. All right, so there's different kinds of events. There's a permutation, and that is an ordered arrangement that occurs when, number 1, no item is used more than once. And the order of the arrangement makes a difference. For example, when we talk about baseball and you have a batting order, it matters if the person hits first, second, third, all the way up to ninth, because the order matters. If you bat out of order, you are out. So there's 13 players on the team, and you need to choose a batting order of having 9 players. So the formula for permutations is n factorial over n minus r factorial, meaning you take 13 objects and you want to have 9 permutations. So n equals the number of objects, r is basically how many you use at a time. So in this case, you'll do 13 factorial over 13 minus 9 factorial. So you can do 13 times 11 times 10 times 9 all the way out, times 7 times 6 times 5 times 4 factorial. So you cancel. So basically you just have to type in 13 times 12 times 11 times 10 times 9 times 8 times 6 times 5, and you get your answer of 259,459,200. If you want to type that in on your calculator, there is a way to do that. So you go second. Actually, sorry, you don't go second. You go math. And then over here at probability is the NPR is number 2 for permutation. So first you have to hit 13. So you go 13, then you hit math, and then you go to probability. And I got to hit the second one. So you go 13, and then down to the second one, NPR, and then you hit 9. And then you hit enter, and notice it gives you the same amount. So that's how you would type it in your calculator for the permutations. So below is the formula. Remember, N is the number of objects, R is how many you're using at a time. So if a corporation has 7 members on its board of directors, how many different ways can it elect a president, vice president, secretary, and treasurer? Notice these are all unique offices. It matters if you're treasurer as opposed to president. They hold different titles. So the order matters. It's a permutation. So in this case, you have 7 members, and you're picking 1, 2, 3, 4 at a time. So when you type that in on your calculator, you can go 7 and then math permutation 4. So you get 840 different ways that you can do that. All right, a combination is when you're selecting items from the same group. No item is used more than once, but the order doesn't matter. Let's say instead of picking up here a president, vice president, secretary, and treasurer, instead, let's say you just wanted to form a committee. That would be a combination because it doesn't matter if you're picked first or fourth as long as you're on the committee. So combinations, when N is the number of objects and R is how many at a time, combinations, it's N factorial over N minus R factorial times R factorial, because you want to get rid of the repeating ones. So for example, how many 4-card hands if you play cards, how many 4-card hands can be dealt from a deck that has 16 different cards? So you have 16 cards and you're making a combination of 4 at a time. And it doesn't matter if you give the person the card first or if you give the card fourth, it's still in the hand. So when you do combinations, you type in 16 first, and now you hit math, and then you go to probability, and then notice number 3 is NCR, which stands for combination, and then you go 4. And you get 1,820. There are 1,820 different combinations. All right. That concludes our video for this evening. If you have any questions, please feel free to ask in class, and I hope this has been helpful and you have a good weekend.